Well, my study was taking a look at two different perspectives that have been used to interpret student performance in general, and then I wanted to apply those two perspectives to organic chemistry. So one of them was continuities and the other was discontinuities. And I wanted to take a look at those two perspectives, specifically at some of the factors that predict students' achievement in organic chemistry. So why organic chemistry? Well, we know that every year thousands of students enroll in challenging science and math classes, and organic chemistry is definitely one of those stumbling block classes. It's a gatekeeper class, as it's called. The reason is because the number of students that actually enter the class, and if you're interested in pursuing an advanced degree or your undergraduate in chemistry or many of the STEM domains, you have to take at least a semester of organic chemistry. And if you're interested in pursuing any type of, well, I shouldn't say any type, a lot of STEM professional related fields like medical school or dental school, you have to take at least a semester. And many times you take the actual year-long course, and then there's an additional year-long lab course. And schools have, with the departments within themselves have organized workshops to help students do better in these classes, but it's still, and they focus mainly on problem solving, but from a cognitive perspective, it's still a bit unclear how these workshops help students do better. So as I mentioned, one of the things I was interested in taking a look at was students' problem solving. But we know that students could actually solve problems without really understanding the meaning that underlie those problems. So they could get the correct response on the problems that are on the question, but when you kind of probe them a little bit deeper, you'll find that some students may not really understand the meaning that underlies those problems. So we got to go deeper than just their performance on a problem set. We have to take a look at their conceptual understanding in conjunction with their problem solving. So that was the second factor I was interested in taking a look at. And finally, the third deals with student study activities. This was something I thought was important, something that we wanted to include in the study, because we want to see how are students studying for organic chemistry. Is this helping them build a conceptual understanding, and does that aid in their problem solving as well? And I was interested in taking a look at underrepresented students that are considered underrepresented by the National Science Foundation, and these students are African American, Latino students, and some Pacific Islander students as well. We know that the numbers are increasing overall in society in general, based on census data, and in K-12 we've seen a huge increase in the number of Latinos, and this is projected to continue increasing as well. And there was an interesting study that came out of UCLA. This is the Higher Education Research Institute, and what they did was that they surveyed incoming freshmen. This is not just at UCLA, this was at hundreds of colleges and universities. But they surveyed incoming freshmen, and one of the questions on the survey was, what do you want to major in at this point? And out of all the underrepresented students that participated in that study, about 33% of them, or about a third of them, indicated some type of interest in a STEM domain. So this is inspiring to me, because this tells me that there is a pool of potential students who are interested in some type of STEM domain and want to go on and pursue that. But when we look at their actual aspirations to the graduation rates, what we see is a totally different picture. We see a huge gap. So this study continued to follow students after 5 years. And after the 5th year, they completed another survey, and they also documented their graduation rates. And so for Caucasian students, it was about 35%, which is still pretty low after 5 years. I think, well, maybe average is probably about 5 years. In chemistry at my school is about 5 years for your undergrad.
And so is that graduated in STEM? Or
that graduated in a STEM field. So it didn't have to be chemistry. Asian American students about 40%, and Latino students about 22%. So about a fifth of the students. And this is, again, after 5 years. So to me, these numbers are just too low. They're just too low. I think 22%, even 35% after 5 years is low. Yes.
So that's 22% of the original 1/3.
That's right.
That indicated they wanted a STEM major.
Yeah, that's right. Yes. Yeah. Good point. So as I mentioned, I was interested in taking a look at two perspectives that have been laid out in the literature. One of them is this continuity perspective that suggests that students' performance is going to be due to how much or less they know coming into the class. And this is, this emphasizes students' prior knowledge. It also emphasizes kind of this idea of deliberate practice or the study activities that they engage in to help them build their understanding in a domain or in some class. And the second one was a discontinuity perspective, which this is kind of, it says that your prior understanding is also important, but you also have to consider other factors, possibly due to a student's culture who may not be familiar with the culture of science. And so these were two perspectives that I wanted to take a look at with respect to students' performance in organic chemistry, and I wanted to see, based on my data, which perspective is supported, if either one. And finally, I wanted to take a look at student study activities. Now, the research on this is still mixed. There's some studies that suggest, there was a nice study done by Yuri Treisman out of UC Berkeley that documented student study activities for intro calculus. And he took a look at Asian American students and African American students because he wondered why African American students were performing predominantly worse in his class than Asian American students. And what he found was that there were different approaches to the types of studying that they were doing. So African American students overall tended to study by themselves, whereas Asian American students tended to form kind of these academic fraternities around the class. And what I mean by that is that they used kind of this peer-to-peer learning. They'd get together in groups, they'd share each other's problems, they'd have to justify their responses. So it was this kind of peer-to-peer engagement that they were using, and he inferred from that this might be why Asian American students perform better. And then there's some other studies that picked up off of that kind of support what he found. The second study was also it wasn't a replication of that study, but they also took a look at student study activities based on their ethnicity. And what they found was essentially that there was no differences. That all students essentially used the same study strategies to study for the classes. The only difference was how often they used the strategy, or how long they studied, in other words. So the jury's still out on this one, and so I wanted to take a look at this with respect to organic chemistry. So there were three basic questions that I had going into this study, and because this was an exploratory study, we wanted to establish these kind of questions. So do students cognitive structures, and what I mean by cognitive structures is the way that they structure their understanding around a certain topic. In this case, it was OCHEM. And do their does it vary based on their ethnic group? And do students' problem-solving performance and approaches vary based on ethnicity? And finally, their study activities, and if that varies by ethnicity. And I also wanted to check, based on the study strategies that they were using, how do those relate to their course performance? So for the sample, we had about 90 students from a Cal State system. So these are not Stanford students. And the reason I say that is because I get that question, and so I just want to say that these are Cal State University system students. And we had 41 Asian students, 32 Caucasian, and 17 Latino. And I separated them into these kind of categories because I wanted to take a look at if there was any differences between the groups. And these students already were familiar with some chemistry. They had already taken a year-long sequence of Gen Chem. And if they agreed to participate in the study, what we did was that we had them fill out, we had them complete, we invited them in for an interview session. During that session, we had them complete what are concept maps. I'm not sure how familiar everybody is with concept maps, yes? I see some nodding, okay. So we had them complete concept maps to get at their kind of cognitive structures. And then their problem solving, we had them complete organic chemistry problem sets while they talked out loud. And then before they got to the interview, we had them fill out diaries, a week-long diary, essentially, and they had to document their study strategies. And I'll talk about each of these in a moment. And then to encourage students to participate, we actually paid money, which is pretty good. For 8 hours of your time, you can get 220, yeah.
No African American students in the study?
Yeah, there were. And the reason that I didn't...
There were or were not?
There were. And the reason that I didn't include them in my study is because I was conducting some statistical analyses on these, and there was only 3 students. 3 students. And this is across 2 semesters.
And this is because you couldn't find more?
They weren't enrolled in the class that during that time. And if they were enrolled, students had the option to participate in the study or not. So these, based on the students that participated in the study across 2 semesters, we only had 3. Yeah. So the first assessment was a concept map where we gave students a variety of different terms related to the unit, the specific unit that they came in for that interview for. And we had 4 different interviews that were scheduled across the semester. So for each student, they completed 4 different interviews that captured 4 different important topics in organic chemistry. And we gave them some terms related to that topic, and we asked them to complete a concept map so that it shows their understanding about the relationship of the terms that were given to them. And we scored them on a 4-point rubric from incorrect to scientifically correct. And the way, I should mention, excuse me, I'm going to grab my water. I should mention that the way that we scored them was based on their propositions. So the orange box here, 2 terms and its linking phrase corresponds to a proposition. So what we did was we took a look at each of these propositions, and we scored each proposition based on this rubric. Now, keep in mind, I'm trying to apply these 2 different perspectives that have been used to interpret students' performance. This will give me information about whether students differ quantitatively in their knowledge structures. That is, do students from some ethnic groups perform better or worse based on if we score them quantitatively? So that'll give me information about the continuity hypothesis, which is that some students come in knowing more or less. But it won't give me information about the discontinuity hypothesis, which is that it's a qualitative difference that we're assuming between students' ethnic groups. So I need some type of qualitative information based on their concept maps. So what I did was that I went back and coded the data based on the structure, their map structure, and I used 3 different categories: linear, radial, and network structures. So this would give me information if were there certain ethnic groups that predominantly use some type of category versus others. So the second factor we wanted to take a look at is students' problem-solving sets, and we scored these essentially as correct or incorrect, and they receive partial credit as well. So that's, again, the quantitative way that we scored them, but again, I need some qualitative information so that I could either support or not support the discontinuity perspective. So for that, what I did is I separated students based on their ethnic groups, so I could look for differences between the groups, and then I selected a high and low achieving student in each ethnic group, or in each category, and it was only 2 students. So it wasn't all 41 Asians in the high and low. It was only 1 high student and 1 low achieving student in each ethnic group. And then I analyzed their think alouds for the types of approaches that they use to solve the problems. And finally, the last thing I took a look at was students' study diaries. And what we did is that we emailed students, and this is the larger study, we emailed students an electronic diary that they had to document their academic day. And so they pretty much, and we asked them to be specific about organic chemistry, but what did they study? What were they studying for? How did they study? What materials did they use? How often? Who they studied with? And where they were studying. We wanted to know this type of information. And then we used a framework that's been used before in science ed research and in psych ed research as well. It's called self-regulated learning strategies, and we use these strategies to go back and code basically student study activities. And there's 15 different strategies that are used in this framework. And this provides three examples. So the first one, for example, the student says, "Lecture's so boring, so I study my flashcards." And this would be coded as a memorization strategies. And then so we went through, we compiled their diaries and coded them based on these strategies. So again, I was interested in knowing if students enter organic chemistry with the same amount of, essentially the same amount of understanding between the three different groups that I looked at. And when I ran the analysis, I saw that there was no significant difference in terms of their prior science understanding. And the way I measured prior science understanding was by using their prior science GPA. And so there's questions about that too, whether science GPA is a good predictor of a student's understanding. But this is what I used. And so when I took a look at this, I saw that there was no significant differences in their prior science GPA between Asian and Latino students or Asian and Caucasian students. What I did see was that there was a significant difference between Caucasian and Latino students, indicating that Caucasian students enter organic chemistry understanding with a deeper understanding, well, with more of an understanding based on science GPA than Latino students do. And this was a common trend that I saw throughout all the research questions that I explored. And the reason I bring that up is because I'm trying to find out if whether students' performance is attributable to some qualitative difference between the ethnic groups, or if it's just attributable to how much or less they understand coming into organic chemistry. So keep this in mind. We'll see this trend throughout the rest of the slides. And so I ran another test to look at, based on their quantitative scores on the concept maps, when we scored them by propositions, were there any differences between the groups? And again, we saw that there was a significant difference between Caucasian and Latino students, and no difference between Asian and Caucasian or Asian and Latino. So it was the exact same trend that we seen in the previous slide. So this tells me that it might be, they overlap nicely. The same groups are significant, and the same groups also lack significance. So this provides support for the continuity perspective that indicates that students' prior understanding may be what's affecting their performance on this measure here. And please stop me if you guys have any questions throughout. So then I looked at the type of approaches that they use to solve. I'm sorry. This is the different structures that they showed on their concept maps based on the three categories: the linear, the radial, or the network. And I wanted to take a look at were there any significant differences between groups that where one ethnic group may use a certain type of structure than another. And what I found was that there were no differences between ethnic groups. So essentially all students use the same types of structures, that there was no differences between the groups. The only difference was that some students used more structures than others. And that only showed up on Unit 2, where the predominant cognitive structure was radial. And it's interesting too, because on Unit 4, there was more linear structures than we've seen, and that's actually the same unit that students did the worst in. All students, regardless of ethnicity. And so I want, just as a side note, I dug a little bit deeper to see how that was related to their performance on other measures as well. And it turns out that there is kind of a continuum, and that the concept map structures that you can see by the students' concept map structures, you could place them on this continuum of how much understanding they might have. So the linear structure is has been related to more simple understanding, as a more network structure, which is more integrated and complex. But getting back to the question was whether there was ethnic group differences based on their structure. We saw none. So just to summarize kind of the first question, we saw no ethnic group differences based on qualitative aspects, but on the quantitative aspect we did see the difference, and that difference overlapped exactly with what we saw with the prior science GPA. So this provides support for the continuity perspective. I did the same thing. Okay, my computer's thinking right now. It's deciding whether it wants to go to the next slide or not. Okay, I did the same thing with the problem solving based on their quantitative scores, the correct or incorrect. But again, I saw the same significant groups that we saw with the concept maps. That there was an ethnic group difference with Caucasian students performing better than Latino students, but no difference between Asian or Caucasian or Asian and Latinos. So again, we're seeing the same trend that I saw with the concept maps and with the prior science understanding. And I went back and took a look at the approaches that they used to problem solve to see if some students predominantly use a certain approach over others. And again, what I found was essentially that there was no difference between the ethnic groups. That what I did see a difference was between the students, whether they were a high achieving student, as I categorized them as a high achieving student, or a low achieving student. The lower achieving students tended to use these trial and error type of approaches to solve questions. And so they would kind of go down this one path of understanding, and then they'd say, no, wait, that's not the way you get it. And then they take another way, and then kind of go around the other way. And so they use various types of approaches, some that would lead them to the correct response, but most of them didn't. Whereas higher achieving students use kind of this direct forward-working approach. And this may be because they have a higher understanding, that they understand the material, so they've seen similar types of problems and they know how to solve these problems. So they just say, okay, I take step 1 to step 2 to step 3, and it gets me to the answer. But I saw no differences in the types of approaches that they were using based on ethnic group difference. The only thing that I saw was based on whether they were high or low achieving. So how much understanding of the domain that they had. And the last thing was study strategies. So this is a bar graph that represents the 3 ethnic groups' study strategies, and all 15 are represented here by different colors. And what you'll see is that across all 3 groups, you essentially see the same colors. The only thing is that there's more or less of some, indicating that basically all students use the same types of strategies. It's just that some groups use more or less of a particular strategy.
We've got to turn this off and on.
I was like in the moment. I was in the moment, right? I killed it.
Time for questions. Anybody got a quick question?
Yeah.
Was there any explicit discussion in these environments about how to engage and study and participate in class, or was this all left implicit and then the groups, find out?
No. There was nothing mentioned. We didn't probe them or talk to them about their studying at all. So this was just sending them the email with a diary where they documented their strategies. And then they pretty much just wrote down what strategies that they were using.
Right, but in the classroom itself, and was there any kind of encouragement where the professor would get out and say, hey, go work with groups of students, it's best that you sit down on your own, memorize every possible example problem ever, and give that back to me because that's what I care about.
I didn't know, and keep in mind, I sat in their actual class maybe a handful of times throughout the semester. So it's possible that the professor could have talked to them, just not on the days that I was there, but there was no explicit instruction on how to study for these things.
And reviewing problems is just like going back to old problems and looking at it and saying, oh yeah, I remember how to do this.
Yeah.
It's different than actually doing problems, right?
Yeah. So this is reviewing problems that they had already solved, or that they had already worked out. And I'm glad you bring that up, because we code them as this reviewing problems category. Well, I'll save it for the next slide because I think it kind of highlights, and I'll talk about it a little bit more in the next slide. But yeah, to answer your question, it was previous problems that they were reviewing. Okay, so what we see is that all three graphs basically have the same strategies that students use. The only thing was that some groups use more or less of a strategy. So we saw no ethnic group differences in the types of strategies that they were using. For example, whether Asian students use more reviewing problems than Latino students. At least no significant differences. And so what we find is that essentially students use four common strategies when they were studying for organic chemistry. That's reviewing their text, reviewing their notes, reviewing previous problems, and also organizing. So the organizing strategy could be making flashcards, highlighting information in their notes, or compiling notes that they have for the class. So I wanted to look at these four strategies a little bit further, because I was thinking, well, if students are using these four common strategies, then how is that related to their course performance, their concept map performance, or their conceptual understanding? We say that that's a measure of their conceptual understanding, and also their problem-solving performance. What I found was that there was no correlation between those two outcomes. So the strategies that they were using did not correlate directly with their course grade or with their concept map performance. There was one significant correlation between the category reviewing previous problems and their performance on problem solving. And it makes sense. The more you review problems, when you see those problems that are similar to the ones that you've reviewed, it's likely that you're going to be able to answer those. But even that was a low correlation, 0.29. So it's low to moderate. So this is a bit disheartening for me, because this tells me that students are spending a great deal of time studying for these classes, and they're using these four commonly used strategies, but that these strategies are not helping them directly to their course grade or their concept map performance. And even only one out of the four strategies is helping them was related to their problem-solving performance. So we coded for 15 different strategies, and I wanted to take a look at the strategies that students were not using, because I thought that would be telling as well. If they're using four strategies, but there's a ton of other approaches that they can use, how do those things relate to these three outcomes on the right side? And what I found was that when I included kind of these strategies that made students actively participate in their own learning, so where they had to seek out information from others, where they had to seek out information from their peers or their professor, or even seek out information from other sources, like go to the library, check out another textbook, look online to look for something that you didn't understand in the text that you read. All these strategies were significantly correlated to these three outcomes here. So this tells me that maybe there's something there that we need to take a look further and encourage students to expand their repertoire of study strategies, and not just reviewing text and reviewing notes. Because if you guys have taken organic chemistry, the book that you get is thicker than a Bible, and it's a 2-semester course, but there's so many different terms in that book. So reviewing text and reviewing your notes I think is probably not going to be as helpful as some of the other strategies that you can engage in to help you build a conceptual understanding. So just to kind of summarize the findings, with students' concept maps or their cognitive structures, we saw no differences by ethnicity. The only difference that we saw overlapped with their prior science achievement. And we saw the same thing with problem solving, and we saw no ethnic group differences by their study strategies. All students were using the same strategies, just more or less of it. And so all this provides support for the continuity hypothesis, suggesting that it's a prior performance that is well, I shouldn't say the best, but compared to the two perspectives that I was using, it supports all the evidence that I have supports the continuity hypothesis and not the discontinuity, which says that it may be some cultural factors that either impede or support their learning, but we didn't see that. So I think it's fair to talk about maybe some of the implications, and then also a couple limitations, and a big limitation that I should probably mention, and I'll say those in a bit. But I think designing tutorials that are aimed at improving students' conceptual understanding. So not just having tutorial sessions where students get together with a TA that helps them go over problems, but working with the TAs to develop methods and strategies to help students build their conceptual understanding of the material. And also we need to allocate resources for these tutorials. So in California, about a year, maybe 2 years ago, when we collected the data, and they're still undergoing major budget cuts throughout the education system. And so where we collected our data, the professors were required to take mandatory furloughs. So that means that they were required to skip certain classes that they wouldn't get paid for, but students were still required to cover that information and know about it. So that's what I mean by allocating resources to these kinds of tutorials, workshops, or interventions. Because the majority of students who participate in these, and I think who need them the most, are underrepresented groups. And also, it's important to identify, based on the findings that I have, it's important to identify students' prior knowledge as an instructor, or as a teacher. It's important to know, what are my students coming to class knowing? Even if it may not be about organic chemistry, what is it about general chemistry that they know about, so that I know more or less where to start, instead of assuming that all students start in the same place. And maybe we can adapt instruction, maybe front load instruction, so that we cover the fundamental stuff during the first few weeks. We take it a little bit slower to make sure that we cover it well. And then we can start building and speeding up the lecture. And I know for K-12, this is a bit difficult because there's so many demands on teachers' time as it is. And the limitations is, I mentioned one of them was the mandatory furloughs. Another one was the college sample that we used. It may not have been the most appropriate sample, because by the time students enter college, they've already spent many years in the formal education system. So it may be that the students who would have showed kind of these ethnic group differences have already been weeded out of the system, and they haven't made it to higher education yet. So I wanna go and pursue, kind of replicate this study in high schools to see whether or not we can detect these differences in high school, or maybe we can't, and this finding just kind of is supported. The second thing, and is based on their prior science GPA, or their prior science achievement. Even knowing their prior science achievement, can we still entangle aspects of students' culture from their prior science experiences? And this is a question that I don't have an answer to right now. And the reason I say that is because I use that as one of my outcomes. This is the thing that I was saying was predicting their performance on concept maps and other things. But it could be that involved in their prior science experiences are these kind of personal life or cultural experiences as well. So I just don't know how to untangle that, or if it can be. I think I'll stop there. I kind of have a future direction slide, but I think this is good, and just answer any questions that you may have. Thank you. Yes.
I was curious on your groups of the Asian, Caucasian, and Latino.
Yeah.
Was one group having a higher proportion of English as a second language versus the other?
English as a second language? No, for the most part, and we didn't document this. So when we asked students their ethnicity, gender, major, and some other demographic information, but we didn't document if they were English language learners or not. Just out of the students that I interviewed, most of them were fine completing the concept maps, talking out loud when they problem solved. There was no interference because of language, but there were a handful of students out of the 90. But at the ones that I've had, I could probably count on one hand. Yeah. More questions, please. Yeah.
So you said that, I mean, you point to as limitation of the study their prior science experiences possibly being entangled with their performance that was measured as a measure of their prior science knowledge, being possibly entangled with some kind of cultural aspects. I mean, but what about their prior experiences in school? Like, I mean, to what extent is the system not accommodating some aspect of
Do you mean like maybe accommodating some groups better than others?
for example, perhaps those who have a longer history of formal schooling, or those who have more role models in college and in graduate school and professors, versus those who are maybe first-generation students and don't have any models of what formal education is all about,
for sure,
rather than putting it on the student and their culture, maybe the
Yeah.
institution or the interaction.
Yeah, no, that's right. And so for this study, we did take a look at it from the student's perspective as you know, as their understanding or not understanding. But there's a multitude of different factors that could go into affecting how a student does, or you know, whether they perform well or not so well in their courses. And you know, there's a variety of different factors. I mean, you know, there could have been family problems that day when they had the test assigned. I mean, it could be, you know, institutional factors that are embedded within the institution that are affecting students. So you're right. I think that's a limitation that for this study, this was our angle here, and this is how we explored it. It's a small slice of the pie, and you know, but for this study, this is the approach that I took. But I totally acknowledge that there are a variety of different other factors that could have affected or could have skewed these results.
But the implication, though, it seems to me like one of the implications is that the K-12 system is underservicing certain populations as measured by the pre-knowledge measure that you made. I mean, they're coming out of K-12 with lower
That's
preparation
a good point.
than another group of students. And the question is, well, we know that.
Yeah. Yeah.
And that's important to know, and then so we can get to operate on.
Yeah.
Hopefully not blaming the teachers. Other questions?
Yeah, I have another one that kind of builds off of that. I was curious if you took any measure on students, their own expectations or their self-efficacy, how well they would do based on their prior, and if that had any potentially any influence on anything.
No, we didn't. We didn't collect any self-efficacy kind of information. We didn't. You know, identity would have been another, maybe information on their personal identity as relating to being in science or conflicting with that. We didn't collect that type of information. But I will tell you that, and I don't have formal numbers on this. This is just kind of a more or less thing based on the students that I've interviewed. Is that I would ask students after they completed the problem, how confident are you that you solved the problem correctly? And I think the majority of the time, female students tended to be harder on themselves than male students, who would say something like, you know, it's just the way the problem was worded, and that's why, you know, I don't know, I'm not so sure, but it's because of the way the problem was worded. The next one will be fine, I'll get it. But some female students were kind of like, well, you know, I'm really not sure. I didn't study the material that good. Basically, that it was something that was lacking within me. But again, that's totally speculative, and I don't have formal numbers on that. We didn't explore that, and this is just, you know, a trend that I started noticing after several interviews. Yeah.
Other questions? All right, well, let's thank the speaker one more time. And I
Hey,
guess
since we have like a couple minutes,
Yeah.
let me turn the floor around. Do you have any questions for us? So this is a motley crew
Motley.
of really fascinating people
Yeah.
that you haven't met all of. So you might have some questions
Yeah,
for us, like,
Yeah, I guess
what
I
is somebody doing here
Yeah.
from architecture and engineering? That's kind of cool.
Yeah, it definitely is. I mean, this is, I've been here since Sunday, and been telling Val, Aaron, and Noah that this is amazing to see this kind of turnout from so many different disciplines that are interested in issues of science education. You definitely do not see this a lot at other campuses, especially, we're having a lot of difficulty joining forces even on my campus. Where we're doing this study. The study didn't take place on the campus, but the resources are there for us. But it's just not happening right now. So I guess questions. I mean, I would like to talk with each of you and just say, hey, what's your experience? What's your background first in science, and what's kind of your experiences in the programs that you participated in? What kinds of students are in your class? Predominantly underrepresented students. How do you work with those? How does that differ? I mean, we could, I don't know if I have any specific question that you can kind of give me a response to right away, so I think I might hold them until I corner you while you walk out.
Anybody got anything in particular they want to share about the experiences of, because there's a lot of new people here, at least for me, from when I was here in fall.
Back when I used to hang out.
Back when I ran the show. No, just kidding, I never did that. What brings you to this group? If a couple of you can volunteer and just say a couple of words about that, I would appreciate it.
Am I correct? Is this is deeper, but so it's just that there's a bunch of acronyms that have been coming out, and I'm trying to get it straight. This is deeper, the interdisciplinary based education research. What does that mean, you folks? Yeah. So just kind of like, what does that mean? What kind of students do you work with?
Well, I'll partially address what Valerie said and partially that.
Yeah.
So I'm a graduate student in physics education research.
Okay.
So I work primarily in physics. Largely I just come to these meetings because they're absolutely fascinating, and I get to see a lot of what some other people are doing, what the other people in other disciplines are doing. When I actually decided to come here for graduate school, this kind of connection between like the School of Education and physics was one of the biggest things that drew me here. Because a lot of the other groups, the other big PER groups, there's not a lot of connection between the School of Ed. I'm taking my first School of Ed class this semester. I'm really psyched for it. So I really like that. Unfortunately, in physics, we don't get nearly as much of the underrepresented minorities there, and far less women than we would like also. But it's really interesting stuff. I love hearing about it. So.
Thank you.
Thank you. So my background, I'm new to this group too, and I work for an environmental research institution, the Education Outreach Group. My background is as a climate scientist, and I started working for Education Outreach 32 years ago. And I'm working on a climate change project right now, but I'm really interested in getting into education research.
Yeah.
We're actually just thinking about writing a proposal to NSF about addressing diversity in geosciences at K-12. So
Awesome.
your talk is extremely relevant, and I want actually project to go forward.
Yeah, thank you.
I'll jump in. So I finished my chemistry degree last spring, and I came to this. Thank you. Still very happy to be done. I started coming to this group about the last year because I was realizing that I was becoming less and less interested in the research I was doing and more in stuff related to teaching. And for a while, I thought that I wanted to do a postdoc in some sort of science education research.
Yeah.
But right now, I'm an instructor in the chemistry department, and I'm having a blast.
All right.
But I can say what we should say is that in chemistry, if you want to do this kind of stuff as a graduate student, it has to be kind of on the down low.
Yeah, same thing at Stanford.
Yeah, like my advisor was like, "Oh, you keep doing that teaching stuff."
Yeah.
She wasn't real thrilled about it. But I pursued it, and it was good. So I come here because it's fascinating, and less maybe because I want to do research, but I want to find out about the research that's happening and how I can incorporate that kind of stuff into my classes.
Awesome.
So this semester I have 200 students in Intro Chem. There is quite a diversity, at least when I look at 200 faces of people, and I know that there are programs that are designed to help some of those subgroups in other parts of the campus. So engineering has a bunch of students in my class, and they have some extra support program thing that I don't know a lot of details about. And then there's student academic affairs. Something has a co-seminar that's like additional tutorial problem session, like working through concepts of things. So there are other things that support my class, but I don't have a lot of like tutorial program stuff or things in my course right now.
This is first semester Gen Chem or second?
This is intro, so it's like the precursor class to Gen Chem for people who want more support.
I see. Okay, gotcha.
And I asked them on their first homework, like, why are you here? And I have, 200 responses, and a lot of them are, I need to go on to med school, but my chemistry doesn't seem good enough, or I don't think I'm ready for the next class, or something.
That it would be really a fun study for you to do, even if you don't do it.
I like data.
Is kind of like looking at the impact of that class on either retention or
that would be cool.
In the major. They do this in applied math. There's
Right.
a special Calc 1 class, and we've been able to demonstrate. It's always we when the result is good. I have nothing to do with this research. It's been demonstrated that people who took they were already, measured as at-risk students. They took this year-long calculus course and were virtually indistinguishable from the other students at the end of that course. And so I bet you'll find something similar. It's pretty interesting and
I'd be
very
interested in
important.
pursuing that. I just don't know how I'm allowed to look at people's grades or whatever down the line. If somebody wants to do it, look at my kids. I'm in.
That's awesome.
So we better get going because he's got to get to the airport. And thank you guys all, and thanks for
Thank
joining
you. It
us.
was nice meeting
All
everyone.
right, thanks, Enrique.